So for example 2, same issues going on. It's an expand problem. It says expand. And again, when it says expand, the first thing I'm going to focus on, I'll see object times stuff. I want to make sure each of those objects is as simple as possible. So real quick, let's do a quick survey. Let's go to Alex first. Is there anything whatsoever wrong with this object?
Yeah.
What's wrong with it?
Well, A needs to go to the bottom, and B is like not even there.
Very good. We have b to the 0 power, which makes 1, which times 1 doesn't do anything. A needs to move to the bottom. So we have a negative power, we have a 0 power. Those two guys have to be fixed. Okay, and if we fix them the way Alex suggested, C is going to stay right where it's at. A cubed is going to move down. And b to the 0 makes 1, which that's going to be our top because we have to have a top to have a fraction at the bottom. Okay, Emilio, do you see anything wrong with this term here, this object? Again, what we're looking for is negative powers, 0 powers, or too many of the same letter. There are too many C's, right? So there's a problem because we got too many C's. So A squared is behaving itself and B is behaving itself. Where does C belong? To what power? Perfect. C belongs in the bottom of the first power because, again, 2 is bigger than 1. That's where it belongs. 2 minus 1 makes 1. Nathan, do you see anything wrong with that? The green one.
The A and B need to be switched around.
Okay, the A and B are negative powers. They need to be moved around. Minus the 3 is behaving itself. And sometimes people see this minus 3 and they're thinking that has to move to the bottom also. This is 3 to the positive first power, so it's right where it belongs. A negative number is just a negative number. Negative powers are what moves. So A squared belongs on the bottom, B squared belongs on top. Again, that's our first priority. Make each object as simple as possible so you can distribute. Okay, Chris, help me out here. If I multiply 1 over A cubed C times A squared B over C, what do I get?
You get A squared and B first.
Okay.
No, B to the second power.
Why do you think it's B to the second?
No, it's just B.
Okay, very good. B to the first. Okay, and what about the bottom?
A to the third and then C to the second power.
Perfect. This is C to the first. That's C to the first. We're multiplying the same letters. We have the powers. Everything else is just a single object of the same of its own type. So there's only one A, there's only one B. Nothing happens to it. There's only one A. Nothing happens to it. Multiple C's. So we add the powers of the ones that are the same. All right, getting back to Alex. What do you get if you multiply 1 over A cubed C times negative 3 over B squared over A squared?
B squared over A 6 C.
Okay. You said A to the 6th. I'm not going to write that down because it's not right. Try again. We're multiplying A cubed times A squared. A cubed means A times A times A. A squared means A times A. How many A's are there? 5, so it's A to the 5th. In general, when you're multiplying letters of the same type, you're going to add the powers together because that's what the rule comes. That's where the rule comes from. That the powers tell you how many times 2 multiply. So multiply 3, then multiply 2, multiply 4, 5. So make sure that you're adding powers on those instead of multiplying the powers. All right. So that's the distributive property happening. And again, we do the distributive property, and then the last thing we do is verify that each term is as simple as it can possibly be. Emilio, is there anything wrong with the blue term?
Yeah.
What's it?
A cubed and B squared gives me A to the third.
Very good. So we have too many A's, right? Again, that's kind of what you're looking for. Too many of the same letter or negative powers. Those are the issues we're going to deal with here. So if we fix that, Emilio says A to the first power on the bottom, which is exactly right. And then the B and the C squared are behaving themselves, so they stay right where they're at. Again, if terms are behaving themselves, don't mess with them. So B is to the first power, only B. C is to the second power, it's only C. Too many A's, bigger power on bottom. Subtract the powers. 3 minus 2 is 1. All right, Nathan, anything wrong with the red term? Doesn't have to be anything wrong with it, do you think? No, I don't either. There's 1A, there's 1B, there's 1C. All the powers are positive. Everything's fine. So it just stays 3B squared over A to the 5th C. If you do make a modification to something, make sure you bring the other object over. Don't just leave it over there, but make sure you write your good answer over here to the right. But again, that's what a final answer should look like. 1A, 1B, 1C, 1A, 1B, 1C. Positive powers are positive. Do not try to add these together. Powers don't match. This is B to the first, that's B to the second, A to the 5th, A to the first, C squared, C to the first. So no way to add or subtract those. Can't make it any prettier than that. That's as far as we can possibly go. That tends to be the biggest mistake people make. If they understand everything else, they try and just combine these together somehow to make one small object that's prettier than everything else. But that's a pretty answer as far as Algebra 2 is concerned.